Hi, my name is Diego. This is my Lab 9 makeup. So for the first part, we have to look at equation 1 and give a table of outputs showing all the intermediate steps for the equation 1, which was this equation right here. And then here is the table of outputs that I got with showing the intermediate steps here, here, and here, where we have the negation of S, A and not S, and B and S, showing the outputs here once you do the OR, putting these two results together. For part 2 of the lab, we had to build our own AND, ORs, and NOT gates using only resistors, BJTs, and DC voltage sources. In Circuit Lab, the NOT gates were given to us, and we can see that with a low input, we get a high output, and with a high input, we get a low output. Now, for the AND gates, as you can see with both switches open, we get a low output. If we close one switch, we still have a low output. If we close the other switch, we still have a low output. And if we close both switches, we have a high output. For the OR gate, we have this following setup, and as you can see, with both switches closed, we have a high output. If we open this one, we'll have still a high output. If we open the other one, then we have our low input, and if we close just this one, we still have a high output. So these two switches, we can have either one of them open or both open, and we'll still have a high output. For part 3 of the lab, we have to use Circuit Lab to draw symbolic schematic using logic gates for a 2-to-1 multiplexer with ANDs, ORs, and an inverter. And this is what I got for my inverter. As you can see, if we open up all of them, we get 0, which matches the input that we had calculated in our table. If we close, for example, the selector at this point, we still have 0. And if we look at our table with just the selector on, we still have 0. If we close A at this point with the selector closed, we'll have 0 still, matching this one right here. We still have 0. And if we close B as well, then we'll have a high output. And if we see at the table, we also match that one. For part 4 of our lab, we had to use Tinkercad to build our 2-to-1 multiplexer using ANDs, ORs, and NOT gates. And here we follow the code of yellow wire being input A, blue wire being input B, and our green wire being our selector wire. So this is the design that we came up with, and we have A right here, B right here, and our selector right here. And the results that we got with that were the following. So we have our NOT gates, our AND gates, and our OR gates, and if all of them are low, we get a low output, and you can see here the light is off. If we have our selector being on low and our input A being high, we still have a high output, and the light is here. And then these are the following and the following combinations. And as you can see, if all of them are on, then we also have a high result. And then we had to build a schematic for a 4-to-1 multiplexer using several 2-to-1 multiplexers. And the solution was the following. We use one multiplexer here, one multiplexer here, and then we get the output from each multiplexer, put it into a third multiplexer, and then that is the output that we want, where we would have inputs A, B, C, and D here, and then we have our selector wires right here, and this is the final multiplexer that we would have. For the in-lab section of our lab, we had to actually build our multiplexer and demonstrate that it would work, matching the table that we did in the first part of the lab. So here's our multiplexer. We have our LED right here, our NOT, our AND, and our OR gates. And then here we have our A wire, we have our B wire being the blue, and our green is our selector wire. And as you can see, based on the table, with A, B, and S being low, we have a low output, which is what we have right here. If we move the A wire to high, we have a high output, which would be this value right here, and we get a high value. If we put the selector in high right now, we get a low output, and that would be this value right here, where we have A high, B being low, and S being high. We get a low output. And if we put B in high, we would also have a high output, matching this row right here, and we get a high output. For the last part of our lab, we had to use our 2-to-1 multiplexer to select different frequencies. So input B, which is the blue wire, is connected to pin 8, and it has a frequency of 0.5. Input A is the yellow wire, and it has a frequency of 10 Hertz. So we're going to change the light blinking frequency from low to high using only our selector wire. As you can see, with the selector on high, we have the blue wire being selected with 0.5 Hertz frequency, so the light turns on and off at that frequency. And if we go to the high frequency, selector on low, get the power coming in and out of wire A, which was changing at a 10 Hertz frequency. Here's my Arduino code, and thank you.